Good morning, dear kids and parents. Hope you all are doing very well at home. Dear kids, today we are going to continue with our fourth chapter, that is heat. We had gone through some kinds of thermometers. Okay, so now in this we will go through the transfer of heat, how heat transfers. Okay, so heat flows from a hotter object to colder object. Okay, heat always flows from hotter object to colder object. It transfers from one object to another. That is hotter to colder. The heat transfers from hotter object to colder object, right? Till what time does it goes on transferring? When both the objects will reach same temperature, transfer of heat stops. Means there are two objects, one is hotter and one is colder. Suppose object A and object B. Okay, so object A is hotter and heat is going on transferring to object B, and once the object B temperature is same as object A, suppose object A temperature is 25 degrees Celsius, okay, and as soon as object B is at a temperature of 25 degrees Celsius, the transfer of heat will stop. There won't be any more transfer of heat from hotter object to colder object because both are going to be equally hotter. Okay, now see, there are types of methods for transfer of heat. There are three types of methods. First is conduction, convection and radiation. Okay, we'll see these three methods in detail. When the conduction takes place with solids, convection takes place with liquids and gases, and radiation do not require any medium. Okay, radiation method does not require any medium. Now turn by turn we'll see all three of them. First one is conduction. Transfer of heat in solids. Okay, as I told that in solids convection takes place. From one object to another when two objects are in direct contact. When two objects are in direct contact, heat transforms from one to another object directly. For example, you can see there is a vessel on a stove and it is in direct contact with gas stove. So that heat directly transforms to that vessel. So that is direct contact. So from one object to another when two objects are in direct contact. Okay. Then second thing, when does that transformation takes place through convection is from hotter part of an object to colder part of an object. As I said that from hotter part to colder part heat transforms, right? So see, in this image you can see that there are bricks and metal rod is kept in between, and at one end candle is there. Okay, and on metal rod, what it is done on metal rod, at some distance they have put some wax. Okay, and as soon as that candle burns, what happens? First wax point will start melting, then second one, then third one, and it goes on, and gradually the whole metal rod gets heated. Okay, so now we'll see some of the examples of our day-to-day routine of convection. First one, you can see it's an image of cup and saucer. It's a hot cup of tea and a spoon is kept in that. Okay, heat transfers from hot cup of tea to spoon. It is a direct contact, right? Tea is hot and spoon is kept inside it. So what does it happen? Even spoon becomes hot. Next one is heat transfer from one part to another. In this, what happens? This vessel is kept on gas stove and a big spoon is kept in that vessel. Okay, so gas stove is switched on, heat starts transforming to that vessel, and from vessel it transforms to that big spoon. So that is transforming of heat from one part to another. Okay, now in this there are two things, that is conductors and insulators. What are conductors? The material which allow heat to pass through them easily are conductors of heat. Means the material which allow heat to pass from them. that are conductors of heat. For example, aluminium, iron, copper, that allows heat to transform from them. And next one is insulators. What are insulators? The materials which do not allow heat to pass through them easily are poor conductors of heat or insulators. Means the material which do not allow heat to pass from them, that are known as insulators, or we can also say it as poor conductor of heat. And their examples are wood, plastic, air, water, rubber. These materials do not allow heat to pass from them. They are poor conductor of heat or insulators. Okay. See, there is an example for conductors and insulators. First example which you can see. In first one, it is a vessel kept and on that a spoon is there. So heat is easily transformed from that vessel to that spoon. So that is a conductor. In next image, you can see there is a pen. Okay. Pen is having a handle of wood. So what will happen? The pen will get heated, but it won't allow wood won't allow heat to pass from itself. So wood won't get heated. So that is insulators or poor conductor of heat. Okay. Now we will see convection, second method. And convection takes place for liquids and gases. Now what happens in there? See, first of all, liquids and gases are heated first. They are heated first. As soon as they are heated, what happens? It expands. Okay. And the time it expands, it becomes lighter in weight. And the time they become lighter in weight, it rises up. Okay. So see, for example, there is a glass jar kept and we have taken some water in that. So before that, let's see if there is a hot water, then what will happen with hot water? Hot water will expand. Already it is hot, so no need to heat, it is already heated, so immediately it will expand, and the time it expands, it becomes lighter in weight and it rises up. Okay. And what happens with cold water? Cold water is heavier. Cold water is heavier, so it goes down. Hot water rises up and cold water goes down. So what happens in this jar also? There in between there is a hot water kept. Okay, that down you can see. So that is a hot thing. So what will happen with that? It will get heated with the flame. Flame is there down below that. Okay. So it is heated with that flame. As soon as it is heated, it expands. It expands and it becomes lighter. As soon as it becomes lighter, it rises up. Okay. And from both the side, the cold water is there. So that cold water, what will happen with cold water? The cold water is heavier, so that cold water will go down from both the sides. Again, that will get heated. It will expand, get lighter in weight and rises up. And this process goes on. This process is convection. Okay. Now we'll see one example for that. There's a candle kept down. Okay. One hand is kept at side and one hand is kept above. Top is hot. The top of the candle, that will feel more hot. Why? Air heats up due to convection. Flame is going straight and the air around that, which is up, that is going to be more hotter. So heat that is coming up above the candle, that is more hot because of convection. Okay. Now another example for the same is also hot air balloon. Hot air balloon, you all might be aware about it, right? So in that also what happens, below if you see, there is a flame, there is a fire burnt. Okay. As soon as fire is there, it starts getting heated, and the time it get heated, it expands. The time it expands, it becomes lighter in weight, and as soon as it becomes light in weight, it rises up. Okay. So this is also a convection method. Next one is sea breeze during day. And same thing, we will see two parts. One is sea breeze during day and sea breeze during night. First one we will see sea breeze during daytime. Now let's see what happens in that. Land gets heated faster than the water. Land always gets heated faster as compared to the water. The air over the land becomes hotter and rises up. The air which is there over the land, what happens to air over the land? It becomes hotter, it becomes very hot and it rises up. Because it is heated, as I said, as soon as it is heated, it expands, it gets lighter, and as it gets lighter, it rises up. So same thing happens with this thing. Okay. Then what happens? The cooler from the sea, the cooler air from the sea rushes in towards the land to take its place. The cooler air which is there in the sea, what does it do? It rushes towards the land. As soon as this hot air rises up, the cooler air from the sea rushes to take its place on the land. The warm air from the land moves towards the sea to complete the cycle. Now the warm air which rised up from the land, that moves towards the sea, so that the cycle is completed. The air from the sea is called the sea breeze. So the cool breeze that we got from the sea, that is called sea breeze. Sea breeze is the breeze that we get from sea to land during daytime. Okay. To receive the cooler sea breeze, the windows of the houses and coastal areas are made to face the sea. To get the cooler air from sea, what happens at coastal area? There are houses. Okay, in that houses, what they do? They make windows of the houses towards the coastal area, so that they can get the cool breeze easily. Okay, so this is sea breeze that we receive from sea during daytime. Next is land breeze during night. Now what happens with land breeze during night? At night it is exactly the reverse. Daytime we received cooler breeze from sea to land. Land hotter rises up, hotter air rises up, it goes back to sea and the cycle goes on. Now at night it becomes opposite, reverse. Okay. The water cools down more slowly than land. Land cools down more faster, right? But sea water takes more time to cool down. So the cool air from the land moves towards the sea. So what happened at night? The cooler air from the land, it moves towards the sea at night. This is called the land breeze. The cooler breeze that goes towards the sea from land at night, that is land breeze, and that breeze goes from land to sea. Okay. Now next method is radiation, third method. As I said, radiation does not require any medium to occur. Okay. The transfer of heat by radiation does not require any medium. It does not require any medium, any source to get transferred. Okay. It can take place whether medium is present or not. If there is any medium or if there is not any medium, whatever it is, radiation takes place. Okay. All the hot objects radiate heat. Whichever hot objects are there, each and every hot object radiate heat. Okay. Sunlight reaches us through radiation. Now see, sunlight. We get sunlight directly from sun, right? Is there any medium between us? No. It reaches up to us directly. Okay. See, there are some more examples for radiation of heat. First one is a campfire heat. If you see in a campfire heat is more above it. Okay. And even in microwaves also there are so much of heat. In both these There is no medium to transfer heat. It transfers directly. Okay. Now we'll just see all the three methods together. How does it work exactly? Okay. Now see, there is a fire below. Okay. The fire which is there, it got heated. As it got heated, it expanded. As it got expanded, it got lighter and it started rising up. The time it started rising up, the air above that is hotter. That process is convection. Okay. Now there is a metal rod. Okay. Metal rod, the time it starts heating from the starting, gradually the heat goes on rising and the whole metal rod is heated. That process is conduction. Okay, that process is conduction. And the air beside this flame, sidewise, okay, that is radiation. That is radiation. Okay. Now one more example for that. See, there is a kettle on a stove. The stove element heats the kettle and the kettle heats the water by conduction. Now when the stove is there, stove heats the kettle first, kettle heats the water. So when heat is transformed from one object to another, that is conduction. Water circulating in kettle transforms heat by convection. Now there is a water in the kettle. As we already saw that hotter object, hotter water gets heated, expanded, gets lighter and it rises up. Cooler water from both the side becomes heavier and it settles down, it goes down. So that convection process is done in this with this water in kettle. Okay. Near the stove, air would feel warm due to heat transformed by radiation. Around the stove, even you might have seen, the air around the stove is hot. That is because of radiation. Okay. So this was about conduction, convection and radiation. Now we'll see one example. There are two containers. One is dark colored container and one is light colored container. And if we keep both the containers in sunlight for half an hour, okay, after half an hour, what you will see, dark colored object, dark color containers, there is a water in both the container. That water in the dark colored container will be more hotter than the water in the light colored container. Why is it so? Because dark color absorbs more heat. The dark color, black is a dark color, right? So dark color absorbs more heat and because of that the water inside the dark colored object is hotter than in the light colored object, and the light color reflects most of the heat. It does not absorb, it reflects most of the heat. So the light color object is not that heated as the dark colored one. Okay. Now see, this is the reason we prefer wearing different colored clothes in different seasons. Okay. In that first we will see color of clothes. Okay. In summer we prefer light colored clothes and in winter we usually wear dark colored clothes. In summer we always prefer wearing light colored clothes so that the hotness, the heat will be reflected, it won't be absorbed. Whereas in winter season we prefer wearing dark colored clothes so that it absorbs heat of the sunlight and it keeps us warm. Okay. Dark surfaces absorb more heat and therefore we feel comfortable with dark colored clothes in winter. As I said, that dark colored object absorbs more heat and it keeps us warm, so we prefer wearing dark colored clothes in winter season. And light colored clothes reflect most of the heat that falls on them and therefore we feel more comfortable wearing them in summer. And light color object, what does it do? It reflects most of the heat and so we feel comfortable wearing light colored clothes in summer season because it is very hot, right? Now Wool in winter. Why do we wear woolen clothes in winter? Wool is poor conductor of heat. Means insulator. We had just gone through about conductors and insulators, right? So from that, wool is a poor conductor of heat. Also, wool fibers trap the air in between them. What wool fibers do? It traps the air, means stops the air, as it is a poor conductor of heat. This prevents the flow of heat from our body to the cold surroundings. So this will prevent, this will stop the air to flow the heat from our body to cold surroundings, and this will keep us warmth. So we feel warm. Air cannot enter that woolen clothes, so that we won't feel cold, and the warmth of our body won't go out in the cold atmosphere, cold surrounding. So this keeps us warm. This is the reason we like to wear woolen clothes, as it is a poor conductor of heat. Okay. Next is cotton in summer. We wear woolen clothes in winter. Okay. And we saw why do we wear woolen clothes in winter. Now cotton clothes in summer. Why we prefer wearing cotton clothes in summer? Cotton is very thin fiber and cannot trap air. It is very thin fiber. It is very comfortable. It is very thin. And as it is thin, it does not trap air. Trap air means it does not stop air entering clothes. Okay. Thus it cannot prevent loss of heat from our body. And this is the reason it keeps us cool. Okay. It prevents us, it protects us from the heat, and it keeps us cool. Thus cotton clothes are worn in summer months. So this is the reason that we feel cool, we feel good and comfortable wearing cotton clothes in summer, and we prefer wearing that. Okay. Now one last example for this woolen clothes in winter and cotton clothes in summer. Say for example, you are given two blankets. One blanket is single thick blanket. One blanket is thick blanket, and another is two thin blankets. There are two thin blankets. Now in single blanket, what will happen? There won't be extra layer, no extra layer of air. Okay. And in two thin blanket, what will happen? Air will trap. Why will air trap? Because there are two layers of blankets, right? So air will get trapped in that. It won't allow air to enter that. And in single blanket, what will happen? Provide comparatively less warmth. You won't feel that warm in single blanket because air won't trap in that. Whereas in two thin blankets, air will get trapped because there are two layers of it, and it prevents loss of body heat and keeps us warm. So that heat won't be lost from our body to cold atmosphere, and it keeps us warm. Okay. So hope you understood this topic. Thank you so much, dear kids and parents. Stay home, stay safe. Thank you.